What if I told you that somewhere, in another reality, you're watching this video, but in that universe, everything about your life is just slightly different? The choices you didn't make, the paths you didn't take, they all exist somewhere out there, tangled in the infinite web of parallel worlds. This isn't science fiction. It's one of the most electrifying mysteries of modern cosmology. The idea that our universe might just be one page in a vast cosmic library of realities, each with its own version of you, of me, of everything we've ever known. And today, we're diving deep into 25 mind-blowing theories that will make you question everything you thought you understood about existence itself. Imagine standing at the edge of a mirror, only to realize it's not a reflection, it's a doorway. Behind it, another you lives a life where every decision branched into a new destiny. Some scientists believe this isn't just fantasy. Quantum physics whispers about infinite possibilities collapsing into a single reality, while others argue that every outcome must happen somewhere. From the multiverse to the many worlds interpretation, the math behind these ideas is just as staggering as the implications. What if black holes are gateways? What if time isn't a straight line but a sprawling tree, with each branch a new universe? The deeper we look, the more the cosmos seems to defy our wildest expectations. This is where the adventure begins. We'll unravel theories so shocking, they'll make your head spin, ideas that challenge the very fabric of space, time, and identity. Some will sound like pure magic, backed by equations instead of wands. Others will leave you wondering if we're all just specks in an endless sea of realities, each one stranger than the last. So buckle up. By the end of this journey, you might never see yourself or the universe the same way again, because out there in the infinite dark, another version of you is already leaning in, wide-eyed, asking the same thrilling question: what if? Picture the universe not as a single, static entity, but as a bubbling cauldron of space-time, endlessly birthing new realities like foam on the ocean. This is the heart of cosmic inflation theory, the idea that our universe is just one bubble in an endless sea of inflating space, each with its own unique rules. The man behind this revolutionary concept, physicist Alan Guth, proposed that in the tiniest fraction of a second after the Big Bang, space expanded faster than light itself, stretching quantum fluctuations into entire galaxies. But here's where it gets wild. If inflation can happen once, why wouldn't it keep happening forever? Think of it like a cosmic champagne bottle, constantly fizzing with new universes. Every bubble that forms has its own distinct physics, some with stronger gravity, others with no stars at all. In one, light might move slower, in another, time could flow backward. The terrifying beauty of this idea is that anything becomes possible. There might even be a universe where black holes are as common as raindrops, or one where matter never clumped together at all. And the kicker, these bubble universes aren't just theoretical. The math suggests they're inevitable. Once inflation starts, it doesn't stop. It just keeps spawning new pockets of reality, each forever hidden from the other. So while we're stuck in our little bubble with its specific rules, an infinity of other cosmic experiments are unfolding just beyond our reach. Some might be nearly identical to ours, with only the tiniest changes, like a universe where you chose that other job, or where dinosaurs never went extinct. Others could be so alien they defy every law we take for granted. That's the spine-tingling promise of eternal inflation. Somewhere out there, in the vast cosmic froth, every possible version of existence is real. Now, let's take a step into one of the most radical ideas in modern physics, the quantum many-worlds interpretation. Proposed by physicist Hugh Everett in the 1950s, this theory flips our understanding of reality on its head. Unlike the classic Schrödinger's cat thought experiment, where the cat is both dead and alive in a single, uncertain state, Everett suggested something far more mind-bending. Every quantum event, every tiny decision at the subatomic level doesn't just create ambiguity. It splits the universe itself, spawning two or more entirely new realities where each possible outcome plays out independently. Picture this: in one world, Schrödinger's cat is alive, happily stretching in its box, while in another, it didn't make it. But here's the crucial difference: those aren't just possibilities waiting to collapse into one outcome. They both happen, just in separate, branching universes. Every flip of a quantum coin, every electron spin, every choice you didn't even realize you were making, each one sends ripples through the fabric of existence, creating new timelines where every version of events unfolds. The strangest part: this isn't science fiction. The math behind quantum mechanics actually supports this idea. In the equations, all possible outcomes continue to exist. They just diverge into their own worlds. That means somewhere out there, a version of you took that job offer you turned down. Another one moved to a different country, and in some wildly different universe, maybe you never even clicked on this video at all. But before you start wondering how you'd ever meet these other versions of yourself, there's a catch. These branching realities don't overlap. Once a universe splits, it's completely separate. No going back, no crossing over. The only reason we don't notice these endless forks in reality is that we're stuck experiencing just one timeline at a time. So what does this mean for us? If the many worlds interpretation is correct, then reality is far more vast and chaotic than we ever imagined. Every moment is a crossroads, every decision a doorway to infinite new worlds. And that raises a haunting question: just how many versions of you are out there, living lives you can't even begin to imagine? But hold on, what if the multiverse isn't just branching infinitely, but vibrating? That's where string theory waltzes in, with its radical proposal that reality is built not on particles, but on tiny, humming loops of energy. These strings, billions of times smaller than an atom, vibrate at different frequencies to create every particle in existence, like cosmic guitar strings playing the symphony of the universe. But here's where it gets dizzying. To make the math work, string theory requires at least 10 dimensions, 6 more than the 4 we experience, and folded within those hidden dimensions. Shapes called Calabi-Yau manifolds, intricate geometric sculptures that dictate how those strings vibrate. Now, picture this. Every possible way these Calabi-Yau manifolds can fold and twist, every possible configuration corresponds to a different set of physical laws. Some estimates put the number of possible configurations at 10 to the power of 500. That's a 1 followed by 500 zeros, a number so vast it dwarfs every atom in our observable universe. Each one of those configurations could birth an entirely separate cosmos with its own unique physics. In one, gravity might be 1,000 times stronger, crushing stars into dust. In another, electromagnetism could be so weak that atoms never even formed. This is what physicist Brian Greene calls the string theory landscape, a cosmic archipelago of universes, each an island with its own rules. Some might be barren, lifeless voids. Others could be bursting with complexity we can't even fathom. And somewhere in that unimaginable diversity, our universe just happens to have the right cocktail of forces to allow galaxies, planets, and us. But here's the kicker: if string theory is correct, there's nothing special about our universe's settings. We're not the main act, we're just one accidental arrangement in an infinite cosmic lottery. So what does that mean for parallel worlds? If even a fraction of those 10 to the power of 500 possibilities exist, then somewhere out there, a universe might have 5 fundamental forces instead of 4. Another might have time that flows in loops, and yes, there could even be a reality where string theory turned out to be completely wrong. The unsettling beauty of the landscape is that anything becomes possible. The only limit, the boundaries of the math itself. And that leaves us with a haunting thought. If our universe is just one random page in string theory's endless library, what other realities are out there humming silently in the dark? What if our universe isn't just floating in emptiness but stuck to something much bigger, like a leaf drifting on the surface of a cosmic pond. That's the mind-bending premise of Brane Cosmology, a radical offshoot of string theory that reimagines reality itself. The word brain comes from membrane, but don't think of it as anything as flimsy as plastic wrap. These are vast, multidimensional structures, and according to M-theory, the grand unification of string theories, our entire universe might exist on just one of them, a three-dimensional slice adrift in a higher dimensional realm we can't even perceive. Now picture this: floating in that hidden expanse are other brains, other universes, each with their own physics, their own stars, their own versions of history. And sometimes, just sometimes, they crash into each other. The ekpyrotic model takes this even further, suggesting that our Big Bang wasn't the beginning of everything, but the aftermath of a collision between two brains. Think of it like two sheets of paper smacking together in a fourth-dimensional space, unleashing enough energy to birth an entire cosmos. Scientists have even simulated these collisions, watching as ripples of energy cascade through higher dimensions, creating patterns eerily similar to the cosmic microwave background, the afterglow of our own universe's violent birth. If they're right, then every star, every galaxy, even you might just be the echo of a long-forgotten collision between worlds. Here's where it gets even wilder. If brains can collide once, why not over and over? Some theories suggest these crashes could be cyclical, with universes rising and falling in an endless cycle of creation and destruction. One day, trillions of years from now, another brain might come hurtling toward ours, resetting existence with another cosmic thunderclap. But the most haunting question remains: if we're living on a brain, what else is out there just beyond the edges of our perception? Could there be universes so close their gravity leaks into ours, tugging at galaxies in ways we can't explain? Or worse, what if another brain is on a collision course with ours right now, hurtling through dimensions we can't see, toward a future we can't predict? Brane Cosmology doesn't just challenge our idea of reality. It suggests we're living in a cosmic house of mirrors, surrounded by reflections we don't yet know how to see. And if that's true, then the greatest discoveries in physics might not be ahead of us but alongside us, hidden in dimensions just beyond our grasp. Black holes might seem like cosmic dead ends, places where matter and light vanish forever. But what if they're actually the key to unlocking one of the most radical ideas in physics? Enter the holographic principle, a theory so bizarre it suggests our three-dimensional universe, with all its depth, all its richness, might just be a shadow, a projection from a two-dimensional surface at the edge of reality. The story starts with black hole thermodynamics. In the 1970s, physicist Jacob Bekenstein made a shocking discovery. Black holes have entropy, a measure of disorder. And not just a little, their entropy is proportional to their surface area, not their volume. That's like saying all the information inside a box isn't stored throughout its space but written on its walls. Stephen Hawking later confirmed this, showing black holes emit radiation and slowly evaporate, taking that information with them. But here's the paradox: if information can't be destroyed, where does it go? Leonard Susskind, one of the fathers of string theory, proposed an answer that shattered our view of reality. Imagine a hologram, a flat, two-dimensional surface that creates the illusion of three dimensions when light hits it just right. Susskind argued the universe might work the same way. All the information needed to describe every star, every planet, every you could be encoded on a distant, two-dimensional boundary, like a cosmic projector screen. Our perception of depth, of space, of time, just an incredibly convincing illusion. Think of it like watching a movie. The images feel real, three-dimensional, but they're actually just patterns of light on a flat screen. The holographic principle suggests reality operates similarly. The equations even check out. The math of quantum gravity in three dimensions perfectly mirrors the math of quantum field theory in two. It's as if the universe is playing a trick on us, hiding its true, flatter nature behind the curtain of perception. So what does this mean for parallel universes? If our reality is a hologram, then other universes might be projections too, different movies playing on the same cosmic screen, each with its own unique code. Some could be nearly identical to ours with minor tweaks. Others might be so alien they're unrecognizable, and just beyond the edges of our perception, in that shimmering two-dimensional boundary, the secrets of existence might be written in a language we're only starting to decipher. The holographic principle doesn't just redefine reality, it asks us to question whether anything is truly as solid as it seems. If our universe is a shadow, what's casting it? And somewhere out there on another part of that boundary is another projection, another version of everything waiting to be seen. What if everything around you, the screen you're staring at, the air in your lungs, even the memories you hold dear, was just lines of code in some unfathomably advanced simulation? This isn't just the plot of The Matrix, it's a legitimate scientific hypothesis gaining traction among physicists and philosophers alike. At its core is a chilling question posed by Oxford philosopher Nick Bostrom. If civilizations ever reach the technological zenith to simulate conscious beings, why wouldn't they create countless virtual worlds? And if that's true, what are the odds we're living in the original universe? Bostrom's trilemma lays out three grim possibilities. Either virtually no civilization survives long enough to develop simulation technology, or those that do choose not to run ancestor simulations, or, most unsettling of all, we're almost certainly living in one. The logic is merciless. Imagine a future where hyper-advanced beings can recreate history with perfect fidelity, spawning billions of simulated minds to study their own past. Statistically, the number of artificial consciousnesses would dwarf the real ones, making it infinitely more likely that you're one of the simulations. But how would we even know? Some scientists suggest glitches in reality, tiny, unexplained anomalies that hint at the underlying code. Think of déjà vu as a system hiccup, or quantum indeterminacy as processing limits in the simulation's physics engine. Even the infamous double-slit experiment, where particles behave differently when observed, could be seen as a rendering optimization. Why calculate the full state of something unless a conscious observer is looking? The implications spiral outward from there. If our universe is designed, who's running it? Are we someone's science project, or are we trapped in a civilization's entertainment archive, doomed to replay the same history on loop? And what happens if the simulation ends? The scariest part isn't just that this might be true, it's that we may never find definitive proof. After all, how could lines of code detect the programmer? Yet here's the twist: even if we're living in a simulation, it doesn't make our experiences any less real. Pain, love, curiosity, they'd still feel the same. In a way, the simulation argument doesn't diminish existence, it reframes it. Whether we're made of atoms or algorithms, the questions remain: who are we? Why are we here? And if this is all a grand simulation, what's waiting for us when the game is over? What if black holes weren't the end of the universe, but the beginning of a new one? That's the breathtaking premise of Sir Roger Penrose's cyclic conformal cosmology, a theory so audacious it rewrites the entire life cycle of reality. Picture this: instead of a one-way trip from Big Bang to heat death, the cosmos goes through endless cycles of death and rebirth, with black holes acting as cosmic seeds for new universes. But here's where it gets even wilder. Each cycle isn't just a repetition. It's a transformation, a cosmic reset where the laws of physics themselves get a fresh start. Penrose's vision hinges on something called conformal rescaling, a mathematical trick that lets you stretch and shrink spacetime without losing its essential shape. Imagine taking the entire faded husk of a dying universe, cold, dark, and empty, and shrinking it down to the size of a pinprick. At that moment, all the vast, meaningless expanse of the old universe becomes indistinguishable from the hot, dense singularity of a new Big Bang. Time and space lose their meaning, and eternity folds in on itself like an Ouroboros, the snake eating its own tail. But how could we ever prove such a thing? Penrose points to eerie patterns in the cosmic microwave background, the afterglow of our own universe's birth. These so-called Hawking points are circular patches of slightly higher temperature, like faint scars on the sky. According to Penrose, they're the remnants of supermassive black holes from a previous universe, their radiation imprinted on ours like cosmic fingerprints. If he's right, then the night sky isn't just a record of our universe's history, it's a graveyard of countless others. The implications are staggering. Cyclic cosmology suggests that every black hole in our universe, every collapsed star, every galactic core contains the seed of a future reality. Our fate isn't to fade into darkness, but to become the raw material for something new. And if the cycles are truly infinite, then everything we know, every galaxy, every life, every moment has happened before and will happen again in endless variations. Yet there's a haunting beauty to this idea. It means that even in the coldest depths of cosmic time, when the last stars burn out and the universe seems lost, something is waiting. A spark, a reset, a chance for the story to begin again. And somewhere in that future cycle, another version of you might be staring up at the same Hawking points, tracing the echoes of a universe long gone, wondering, just like you are now, if the cosmos remembers itself. Black holes don't just swallow reality, they might rewrite it. That's the spine-tingling core of physicist Lee Smolin's cosmic natural selection theory, where every singularity isn't a dead end but a cosmic womb. Imagine a black hole's crushing depths not as oblivion, but as a forge where the laws of physics themselves are reshuffled, giving birth to an entirely new universe with its own unique rules. Picture it like a genetic mutation in the DNA of spacetime, where our universe's constants, like gravity or the speed of light, might shift just slightly in the next iteration. Smolin's vision turns cosmology into something almost Darwinian. Just as life evolves through natural selection, universes could evolve through black holes. The more black holes a universe produces, the more offspring it spawns, meaning universes that optimize for black hole creation would dominate the cosmic landscape. And here's the kicker: our universe's laws seem suspiciously fine-tuned to make black holes possible. The strength of gravity, the mass of protons, even the lifespan of stars. All these factors align in a Goldilocks zone that allows singularities to form. Coincidence or evidence we're part of a lineage of universes sculpted by this relentless selection? Think of it like a fractal tree of realities, each branch a new universe blooming from the singularity of a collapsed star. Some branches might wither universes where gravity is too weak to form galaxies, or where atoms can't even hold together. Others thrive, their physics perfectly tuned to birth endless black holes, which in turn spawn even more universes. Over cosmic time, the multiverse becomes a vast garden of possibilities, with our universe just one flower among countless others. But the most haunting implication: if Smolin is right, black holes aren't destroyers, they're creators. Every time one forms somewhere beyond our perception, a new cosmos flickers to life. Maybe in that universe, time runs backward or dark energy doesn't exist. Perhaps in another, black holes are even more abundant, seeding a cascade of new realities in an exponential explosion of existence. The beauty of this idea is how it turns destruction into genesis. A dying star's collapse isn't an end, it's a beginning. And if that's true, then somewhere out there, our universe's own black holes are already spinning up new worlds, each one a wild experiment in the laws of physics. Who knows, maybe in one of them, another version of you is staring at the night sky, wondering the same thing. Time isn't a river flowing in one direction. It's more like a frozen landscape where every moment that ever was or will be simply exists, laid out like coordinates on an infinite map. This is the block universe theory, a view of reality where past, present, and future aren't unfolding, they're already there, fixed in the fabric of space-time like frames in a cosmic film reel. And if that's true, then alternate histories aren't separate universes at all, they're just distant regions in this vast, unchanging four-dimensional structure. Think of it like a sprawling library where every book is a timeline, every page a moment. The story of your life is already written, not just the choices you've made, but every possibility you could have made, branching out like threads in a tapestry. From this perspective, the you who became an artist instead of a scientist isn't in a parallel dimension. They're just a few shelves over in the grand archive of existence, their life as real and unchangeable as yours. Scientists visualize this with space-time diagrams, graphs where time is an axis just like space, and every event is a point with coordinates. A single line might represent your life from birth to now, but the diagram also shows all the paths you didn't take, stretching out like ghostly echoes. The block universe doesn't play favorites, it treats every possible version of events as equally real, just separated by the geometry of space-time itself. But here's where it gets haunting. If the future is already out there, waiting like a destination on a map, does free will even exist? Or are we just passengers tracing routes that were carved into reality long before we took our first breath? Some physicists argue that our sense of time passing is just an illusion, a trick of consciousness that makes us experience one slice of the block at a time. Like an ant crawling along a tree branch, we only feel the bark beneath our feet, never the whole tree. Yet the block universe offers a strange comfort. It means every moment, every joy, every heartbreak is eternally preserved, untouched by entropy or decay. The day you were born, the day you'll take your last breath, the day humanity first set foot on Mars, they're all equally real, all equally now, depending on where you're standing in the vast, unchanging landscape of existence. So the next time you wonder what might have been, remember, somewhere in the block universe it is, not as a fleeting thought, but as immutable as the stars, a thread in the tapestry waiting to be seen. Now, let's plunge into one of the most unsettling ideas in all of physics, the nightmare scenario known as Boltzmann brains. Imagine floating in eternal darkness, utterly alone in the void. No stars, no planets, no universe, just you, a naked, self-aware consciousness flickering into existence for a fleeting moment before vanishing back into the abyss. This isn't a horror story. It's a real possibility lurking in the equations of thermodynamics, and it suggests something terrifying. You might not be who or what you think you are. Here's how the nightmare unfolds. In an infinite, chaotic cosmos, even the most improbable events can and will happen given enough time. Particles jittering in the quantum foam might randomly arrange themselves into a fully formed brain, complete with fabricated memories, sensations, and even the illusion of a lifetime of experiences. These hypothetical entities, dubbed Boltzmann brains after physicist Ludwig Boltzmann, wouldn't be born. They'd just pop into existence, fully convinced they're real people living in a real world until the instant they dissolve back into the void, their entire existence lasting less than a blink. Think of it like static on a cosmic TV screen. Amid the noise, a coherent image might briefly flash, a face, a landscape, even an entire fake reality. A Boltzmann brain is that fleeting image, a glitch in the cold machinery of the universe that believes it's alive, and here's where it gets personal. Statistically, in an eternal, infinite multiverse, Boltzmann brains should vastly outnumber real, biologically evolved minds like yours. So ask yourself, how do you know you're not one? How can you be sure the world around you isn't just an elaborate hallucination, a temporary fluke in an endless sea of chaos? Scientists recoil at this idea not just because it's creepy, but because it undermines all rational thought. If most conscious entities are Boltzmann brains, then even our trust in science and logic could be a random accident, a quirk of quantum noise rather than a reflection of true reality. Some physicists argue this absurd conclusion means our understanding of the cosmos must be wrong. that there's a deeper law preventing such madness. Others whisper that the void might already be teeming with these phantom minds, flickering in and out of existence, each one screaming into the dark, convinced it's the only real thing in the universe. So the next time you feel the warmth of sunlight or the grip of a loved one's hand, pause for a second. Is this real, or just the dying gasp of a Boltzmann brain, spinning its final, desperate fiction before the darkness takes it? The universe isn't just stranger than we imagine. It might be stranger than we can imagine, and that's what makes this theory so chilling, not just the science, but the question it forces us to confront. How do any of us truly know what's real? What if you reached for a glass of water, only to realize your reflection in the mirror was also reaching, but not as a copy, as a completely separate being living in a flipped version of reality? This is the spine-tingling premise of mirror matter universes, where the fundamental rules of physics aren't just different, they're inverted. In these parallel worlds, the very fabric of existence violates parity symmetry, meaning left and right aren't just directions, they're the boundary between realities. Picture a universe where every galaxy spins clockwise instead of counterclockwise, where screws tighten to the left, and even the DNA inside every living thing spirals the opposite way. In our world, the molecules essential for life, like sugars and amino acids, have a specific handedness. They're almost always right-handed, but in a mirror universe they'd be left-handed, like a perfect photographic negative. That means every biochemical process, from photosynthesis to digestion, would follow a reversed blueprint. A sip of water in that world might be poison to us, and our oxygen could suffocate mirror life. The wildest part, this isn't pure speculation. Particle physics already hints at parity violation, the idea that the universe prefers one direction over another. When scientists watched cobalt-60 atoms decay in the 1950s, they were stunned to see electrons flying off asymmetrically, as if the cosmos had a hidden bias. If that asymmetry runs deeper, it could mean mirror universes aren't just possible, they're inevitable. Now, imagine life evolving in such a place. Trees might grow in twisting, opposite spirals. Animals could have hearts on the right side. Even their brains might process logic in reverse, turning their art, music, and math into eerie distortions of our own. Some theorists suggest these mirror beings could be living among us right now, made of shadow matter that barely interacts with our own, like ghosts sharing the same space, forever separated by the twist of a cosmic kaleidoscope. But here's the haunting question. If we ever encountered a mirror universe, would we even recognize it as alive? Or would its reversed physics render it utterly alien? A funhouse mirror version of reality where every rule we trust is flipped? The answer might lie in the stars. If astronomers ever spot a galaxy spinning the wrong way or detect molecules with inverted chirality drifting through space, it could be the first clue that our universe isn't just one of a kind, it's one of a pair. And somewhere out there, in the silent dark, your mirror twin might be staring back, wondering the same thing. What if every equation scribbled in a notebook, every formula ever dreamed up by a mathematician, wasn't just a tool to describe reality, but reality itself? That's the staggering claim at the heart of Max Tegmark's mathematical universe hypothesis, a theory so radical, it suggests our cosmos isn't just described by math, it is math. Not in a poetic sense, but literally. In this vision, the universe isn't made of particles or strings, but of pure, immutable mathematical structures, patterns that exist independent of time, space, or even physical laws. And if that's true, then every possible mathematical system, no matter how bizarre, corresponds to a real, physical universe somewhere in the grand tapestry of existence. Imagine a cosmic library so vast, it makes the multiverse theories we've explored so far seem quaint. Instead of shelves filled with books, this library holds universes, each one defined by its own unique set of equations. In one section, you'd find realities where Euclid's geometry holds absolute sway, with perfect circles and parallel lines that never meet. Flip to another, and you're in a world governed by fractal equations, where every object repeats its shape infinitely at smaller scales. Somewhere in this library, there's a universe where 2 plus 2 equals 5, not because the math is wrong, but because the very fabric of that reality bends logic to fit its rules. Tegmark calls this the level Roman 4 multiverse, the ultimate frontier of cosmic possibility. Unlike other multiverse theories that rely on quantum branches or bubble universes, level Roman 4 skips the physics entirely. Here, the only thing that determines a universe's existence is whether it can be described mathematically, no matter how alien its properties, a reality where time moves in discrete jumps like frames in a film. It's in there, a cosmos where gravity repels instead of attracts, that too. Even universes with no matter at all, just swirling equations of pure topology, have a place on the shelf. But how could something as abstract as math physically exist? Tegmark argues that we've been thinking about it backward. We assume math is a human invention, a language we created to decode nature. But what if math is the base layer and we're just temporary patterns flickering within it? Think of a chessboard. The rules of chess aren't physical. They're abstract constraints that give meaning to the pieces. In the same way, mathematical structures might be the invisible frameworks that generate what we call reality. The kicker: this means the universe doesn't compute the math, it is the math. Now here's the mind-blowing implication. If every consistent mathematical structure exists as a physical reality, then somewhere out there, there's a universe where the number pi isn't 3.14 but 4.27. One where circles can't exist, or where the very concept of number operates in dimensions we can't fathom. These aren't just thought experiments, they're places as real to their inhabitants as our universe is to us. Critics push back, of course. How could a universe with no causal laws, no observable physics, even be called a universe? Tegmark's answer is simple: we're limited by our perception. To a fish, water is invisible, it's just how things are. Likewise, we might be swimming in a sea of mathematics so fundamental, we don't even recognize it as such. So the next time you solve an equation or sketch a graph, pause for a second. You might not just be doing math, you might be glimpsing into another world, one where those symbols aren't scribbles on paper, but the bedrock of existence itself. And somewhere in that infinite library of numbers and shapes, another version of you could be staring back, working through the same problem, in a universe where the answers are entirely different. What if the universe isn't just filled with consciousness? What if it is consciousness? That's the mind-bending essence of panpsychism, a theory that turns the material world inside out by suggesting every atom, every star, every ripple of space-time holds some flicker of inner experience. Not in the way you think or feel, but in a way as fundamental as mass or charge. And if that's true, then you reading these words might just be one thread in a vast, shimmering tapestry of parallel minds, each one dreaming its own version of reality into existence. Think of it like this: when you close your eyes and dream, your brain constructs entire worlds with their own logic, their own physics. Now imagine that on a cosmic scale. What if our universe is the dream of a higher dimensional mind, while somewhere else, your thoughts are the building blocks of another reality? The quantum realm already blurs the line between observer and observed. Particles don't settle into definite states until measured, as if reality itself is waiting for a conscious nudge. Panpsychism takes this further, proposing that consciousness isn't emergent. It's elemental, woven into the fabric of existence like gravity or light. Here's where it gets dizzying. If consciousness is fundamental, then every possible configuration of it must exist somewhere in the multiverse. Alternate versions of you aren't just doppelgangers in parallel worlds, they're other centers of experience, living their own lives with the same vividness you feel right now. One might be a painter in Paris, another a monk on Mars, each one convinced their reality is the only one. And just as your dreams shift and fracture, these parallel minds might bleed into one another at the edges, creating fleeting moments of déjà vu or unexplainable intuition. Consider the fractal nature of dreams, how a single symbol can unfold into an entire narrative, how time stretches and compresses unpredictably. Now apply that to the cosmos. What we call physical laws could be the stable patterns in an infinite field of conscious potential, like recurring motifs in a billion different dreams. Black holes might be cosmic neurons firing signals across dimensions. Quantum entanglement, just two facets of the same universal mind, communicating faster than light because they were never truly separate to begin with. The most haunting implication isn't just that other versions of you exist, it's that you might be the dream of one of them. Right now, in some other layer of reality, your parallel self could be lying in bed, closing their eyes and conjuring this exact moment as a fleeting thought. And when they wake up, will your world dissolve like mist, or will it keep unfolding one conscious moment at a time, in an endless dance of awareness dreaming itself into being? Panpsychism doesn't just connect parallel universes, it dissolves the boundary between out there and in here. The stars, the void, the stranger passing you on the street, all of it might be facets of a single, unfathomable mind, playing an infinite game of hide and seek with itself. And if that's true, then the greatest mystery isn't whether we're alone in the universe, it's whether we've ever been separate at all. Deep in the void between galaxies, something impossible is happening. Hundreds of massive galaxy clusters are streaming toward a single point in the cosmos like leaves caught in a cosmic wind, except there's nothing there to pull them. No supercluster, no dark matter knot, nothing but empty space. Astronomers call this eerie phenomenon dark flow, and it's exactly as unsettling as it sounds. Because if these galaxies are being tugged by an unseen force, what could be strong enough to move entire clusters without leaving a trace? The answer might lie beyond the edge of everything we know. Data from the Planck Space Telescope reveals these galaxy clusters moving at speeds over 2 million miles per hour toward a region near the constellations Centaurus and Vela. That's not just unusual, it defies our entire understanding of cosmic structure. The gravitational pull required would dwarf anything in our observable universe, suggesting an inconceivable possibility. These galaxies might be feeling the tug of another universe entirely. Picture our universe as a sheet of paper floating in a vast, invisible ocean. Now imagine another sheet hovering nearby, separated by millimeters we can't perceive. According to Brane Cosmology, gravity, unlike other forces, could leak between these membranes, subtly influencing matter across the divide. That means the dark flow we're witnessing might be the gravitational fingerprint of a parallel brane, drifting just out of reach in higher dimensional space. Some models suggest these neighboring branes could be staggeringly close, less than a millimeter away in a dimension we can't see. But in that hidden direction, entire universes might be stacked like pages in a book, each with its own stars, black holes, and perhaps even life. Every so often, their gravity bleeds through, nudging our galaxies toward unseen horizons. The Planck telescope's measurements align eerily well with these predictions, showing flow patterns that match what Brane Collisions would produce. But here's the twist. If alternate universes are tugging at us, could we ever find proof? The signals are faint, buried in the noise of cosmic microwave background radiation. Yet if future telescopes detect more clusters hurtling in sync toward the void, it might be the closest we ever get to touching another reality. Until then, dark flow remains one of cosmology's most tantalizing mysteries, a ghostly current in the cosmic dark, hinting that we're not just part of a multiverse, we're being pulled by it. What if every time you made a choice, ate the salad instead of the burger, turned left instead of right, a ghostly thread connected you to the version of you who chose differently? This is the electrifying possibility at the heart of entangled parallel realities, a theory where quantum entanglement doesn't just link particles across space but across universes. Imagine two electrons born from the same quantum event, forever bound so that flipping one spin instantly flips the others, no matter how far apart they are. Einstein called this spooky action at a distance, but what if that spookiness stretches beyond our universe, tying your fate to every could-have-been version of yourself? The math is already wild enough. In the lab, entangled particles react to each other faster than light could travel between them, as if space and time don't apply. Now stretch that idea to the multiverse. When you stand at a crossroads, say, deciding whether to move to a new city, the moment you choose, the universe splits. One timeline carries the you who stayed, another, the you who left. But entanglement suggests these versions might not be fully independent. Some physicists propose that quantum threads could linger between them, creating subtle, invisible resonances. Ever had a dream so vivid it felt like another life, or a gut feeling so strong it defied logic? Those could be echoes of your entangled selves whispering across the void. Here's where it gets even stranger. If entanglement bridges parallel realities, then every quantum interaction in your body, every flicker of thought, every firing neuron, might have counterparts in other universes, all syncopated in a cosmic dance. Your parallel selves could be experiencing joy, grief, or discovery in perfect, silent harmony with your own life, like shadow puppets moving to the same unseen light. Experiments with entangled particles already show this synchronization defies classical physics. Now imagine scaling that up to conscious beings. The loneliness of existence might be an illusion. You could be part of a vast, unseen chorus of selves, each singing a variation of the same song. But the most haunting question remains: if we're entangled with our other versions, could we ever feel it? Some theories suggest déjà vu might be more than misfiring neurons. It could be a fleeting moment of quantum resonance, a glitch where two realities briefly overlap. Others speculate that intuition works like a faint radio signal tuned to alternate timelines, picking up faint whispers of paths not taken. Even creativity might draw from this well, with artists and inventors tapping into ideas their parallel selves already discovered. Of course, skeptics push back. Without a way to test these ideas, they remain beautiful speculation. Yet the same was once said about black holes and the Big Bang until technology caught up to theory. If entangled realities exist, future experiments might find subtle anomalies in quantum systems, tiny deviations that hint at interference from unseen worlds. Until then, this theory offers something profound, not just scientific curiosity, but a poetic reimagining of identity. You might never meet your other selves, but somewhere in the cosmic weave, there's still part of you, bound by threads older than time, spinning stories you'll never hear, but might somehow impossibly remember. Imagine living the same moment over and over, trapped in an endless cycle where every decision, every breath repeats itself across eternity. This isn't just a nightmare. It's a very real possibility in the physics of closed time-like curves, where time doesn't just flow forward. It bends back on itself like a twisted ribbon, stitching the universe into an infinite loop. Think of Christopher Nolan's Interstellar, where Cooper falls into the Tesseract, a mind-bending structure where every moment of his daughter's life exists simultaneously, stacked like frames in a film reel. Now take that idea and stretch it across the entire cosmos. That's the terrifying beauty of time loop, parallel universes, realities where the end is just another beginning, and existence folds in on itself like a cosmic Möbius strip. At the heart of this theory lies Einstein's general relativity, which allows for spacetime to curve so severely that it forms a loop, a path where you could travel forward in time only to circle back to your own past. Picture a roller coaster that doesn't just go up and down, but twists into a perfect circle, letting riders pass the same point again and again. In a closed time-like curve, you wouldn't just remember the past, you could literally walk into it, crossing paths with earlier versions of yourself. Some models even suggest these loops could spawn recursive universes, where every iteration of the loop creates a slightly altered copy of reality, like reflections in a hall of mirrors that get more distorted with each bounce. The math behind this is just as dizzying as the concept. Solutions to Einstein's equations like Gödel's rotating universe or the Tipler cylinder describe scenarios where massive, spinning objects could warp spacetime into these loops. And if quantum mechanics is thrown into the mix, things get even weirder. Every time a particle completes a lap around the loop, it might not just return to its starting point, it could enter a parallel version of the loop, branching into a new timeline. That means a single moment could echo across countless realities, each one a variation on the last. But here's where it gets chilling. If time loops exist, then free will might be an illusion. Every choice you make, every word you say, could just be a replay of a script written by the universe itself. Imagine waking up each morning convinced today will be different, only to live the same day in perfect repetition, like a record stuck on repeat. Philosophers call this eternal recurrence, and Nietzsche famously wrestled with its weight. What if you had to live this life in this exact sequence for eternity? Yet there's a haunting symmetry to this idea. If time loops are real, then somewhere in the cosmic kaleidoscope, another version of you is living this exact moment, but with one tiny change. Maybe they turned left instead of right, maybe they spoke instead of staying silent, and maybe, just maybe, in some distant iteration of the loop, they found a way to break free. The question isn't just whether time loops exist, it's whether we'd ever know if we were trapped inside one. After all, how do you spot the edges of a maze when the walls are made of time itself? What if the Big Bang wasn't the beginning, but just the latest explosion in an endless cosmic war? This is the heart of the Big Splat theory, where universes aren't born from nothingness, but from catastrophic collisions between towering, multidimensional membranes. Picture two sheets of reality drifting in an unfathomably vast higher dimensional space, each one a complete universe with its own stars, galaxies, and laws of physics. Now imagine them slamming together like cymbals in the dark, unleashing enough energy to ignite a new cosmos in the fire of their impact. This isn't science fiction. It's the bold vision of physicists Paul Steinhardt and Neil Turok, who proposed that our universe's birth was just one battle in an eternal cycle of destruction and rebirth. The math behind this is as violent as it sounds. In their cyclic model, our three-dimensional universe exists on a brane, a slice of higher dimensional space floating alongside at least one other. Gravity, the only force that can cross the dimensional divide, tugs these branes together over trillions of years until bang, they collide. The energy of that collision doesn't just create matter and radiation, it resets the cosmic clock, wiping the slate clean for a new expansion phase. Think of it like a phoenix rising from ashes, except the ashes are an entire universe's worth of black holes and dead stars, recycled into the raw materials of a fresh Big Bang. But here's where it gets eerie. The Big Splat isn't a one-time event. These collisions happen over and over in a rhythm as old as time itself. Each cycle begins with a fiery collision, expands into a universe like ours, cools, and then drifts toward another cataclysmic impact. The cosmic microwave background, the afterglow of our Big Bang, might even carry scars from previous collisions, like faint echoes of universes long gone. Some theorists argue that slight irregularities in that radiation could be the fingerprints of branes brushing past each other in the dark. What makes this theory so electrifying isn't just its audacity, it's how neatly it solves some of cosmology's biggest puzzles. No need for a mysterious singularity before time. No need for dark energy to stretch the universe into nothingness. Instead, the Big Splat offers a universe that renews itself, forever dancing on the edge of destruction and creation. Yet the implications are staggering. If branes collide cyclically, then every law of physics we hold sacred, every constant, every particle, might just be temporary. a fleeting arrangement that lasts only until the next cosmic collision reshuffles the deck. Somewhere out there, another version of our universe might have emerged with weaker gravity or faster light or no atoms at all. And if the cycle is truly eternal, then every possible configuration must have happened an infinite number of times. So the next time you look up at the night sky, remember, those stars might not be the first to burn, and if Steinhardt and Turok are right, they won't be the last. The universe isn't just expanding, it's waiting, biding its time until the next collision, the next bang, the next chapter in a story with no beginning and no end. What if the universe isn't just governed by physics? What if it's running on physics? That's the spine-tingling premise of the quantum error-correcting code theory, where reality itself might be a cosmic operating system, and every atom, every star, every flicker of consciousness is just data in an unfathomably vast computation. Imagine your computer crashing, the screen freezing mid-click, except this time it's not your laptop glitching. It's space-time itself, black holes, cosmic blue screens of death, quantum entanglement. Just the universe's way of debugging itself. This isn't just metaphor. The math behind it comes from AD/CFT correspondence, a revolutionary idea in string theory that suggests our three-dimensional world could be a holographic projection from a two-dimensional surface, like a shadow cast by information encoded on the universe's outermost edge. But here's where it gets wild. Just like error-correcting codes in computers detect and fix corrupted data, the fabric of spacetime might be doing the same thing. Every time a particle interacts, every time energy transfers, it's not just physics at work, it's the universe checking its own code, ensuring no cosmic bit flips ruin the simulation. Think of it like a cosmic RAID array, where information isn't stored in one place but scattered across multiple points for redundancy. If one part fails, the system rebuilds it from the backups. In the quantum realm, this could explain why particles stay entangled across vast distances. They're not communicating faster than light. They're mirroring each other like duplicate files, ensuring no data loss. Even black holes, those infamous information destroyers, might just be the universe's way of archiving data we don't have the clearance to access yet. Now picture the glitches. If reality is a code, then sometimes, just sometimes, it might stutter. Have you ever seen something out of the corner of your eye, only for it to vanish when you turn your head, or experienced time seeming to slow down in a crisis? These could be more than tricks of the mind. They might be fleeting rendering errors, moments where the universe's processing lag briefly shows through. Some theorists even joke that déjà vu is the cosmic equivalent of a corrupted save file, a loop where the system accidentally replays a snippet of memory instead of generating new data. The most unsettling implication: if the universe is self-correcting, then reality as we know it might just be the most stable version of the code, the one that hasn't crashed yet. Other, less stable universes could exist in the multiverse's recycling bin, glitching in and out of existence, their physics too buggy to sustain life. And if that's true, then somewhere out there, another version of you might be mid-freeze, trapped in a buffer loop, waiting for the cosmic control plus alt plus del. But here's the kicker: even if we're living in a universe-sized program, it doesn't make our experiences any less real. The warmth of sunlight, the sting of a cut, the ache of love, they're all real to us, regardless of whether they're rendered in atoms or algorithms. So the next time your Wi-Fi drops or your phone crashes, take a second to laugh. If the whole cosmos is running on code, then maybe, just maybe, we're all just waiting for the next universal update. Right now, beneath your feet and all around you, the universe might be sitting on a knife's edge, not just stable, but metastable, like a match balanced on its head, just waiting for the slightest breeze to tip it into flame. This is the nightmare scenario known as the false vacuum theory, and it suggests that the ground beneath our feet, the air in our lungs, even the fundamental laws of physics we take for granted, could all be a cosmic house of cards, one quantum tremor away from collapsing into oblivion. Picture space not as an empty void, but as a vast, invisible energy field, the Higgs field, that gives particles their mass. What if this field isn't in its true, lowest energy state, but trapped in a higher energy, false state, like a ball resting on a plateau instead of rolling to the bottom of a valley? It's stable for now, but given enough time, or the right nudge, it could suddenly tunnel through the energy barrier and drop into the true vacuum, rewriting physics in an instant. The moment that happens, a bubble of true vacuum would form somewhere in space, perhaps light years away, and expand outward at the speed of light, its walls a wave of annihilation. Inside that bubble, the laws of physics would be unrecognizable. Atoms might not hold together, gravity could invert, even the concept of time might unravel. By the time you saw the bubble coming, it would already be too late. The wave front would rewrite reality itself before you could blink, erasing everything in its path without a trace. Computer simulations of this cosmic phase transition are as beautiful as they are terrifying. They show the bubble's boundary as a shimmering sphere, devouring galaxies like a silent, unstoppable fog. One moment, stars burn as they always have. The next, they're snuffed out, replaced by whatever alien physics the true vacuum decrees, the scariest part. The math suggests this could happen randomly at any moment, anywhere in the universe. There's no warning, no countdown, just the statistical inevitability that over infinite time, even the unlikeliest events must occur. Some physicists argue this might have already happened elsewhere. If a bubble formed in some distant galaxy, we'd never know until it reached us. Others counter that the fact we exist at all suggests the false vacuum is stable for now. But here's the chilling thought. If the Higgs field is metastable, then everything we've ever known, every achievement, every memory, is built on a foundation that could dissolve like sand in an instant. Yet there's a strange comfort in this fragility. The false vacuum reminds us that reality isn't set in stone, it's fluid, dynamic, and perhaps more mysterious than we ever dared to imagine. And if the universe is balancing on this precarious edge, then every second we get to experience it is a gift, a fleeting spark in the cosmic dark, so take a deep breath. That air in your lungs, that's the false vacuum holding for now. We've all heard the terrifying legends of black holes, cosmic vacuum cleaners that devour everything in their path, even light itself. But what if those same monsters aren't in points at all? What if they're cosmic backdoors, funneling matter and energy not into oblivion, but into another reality entirely? Enter the white hole, a black hole's mirror twin, a place where nothing can enter, but everything explodes outward in a fiery rebirth. And if Einstein's math is right, these two extremes might be connected like opposite ends of a tunnel, stitching parallel universes together in a dance of destruction and creation. Picture spacetime as a vast sheet of rubber stretched taut. When a black hole forms, it's like pressing a thumb into that sheet, creating a deep funnel. Now imagine poking that funnel through to the other side. The point where it bursts back out isn't a black hole anymore, but a white hole, violently expelling everything the black hole swallowed. This cosmic plumbing is called an Einstein-Rosen bridge, a theoretical wormhole linking 2 points in spacetime. Penrose diagrams, those hauntingly elegant maps of cosmic geometry, show these bridges as hourglass-shaped paths, squeezing the infinite into a narrow throat before flaring out into another universe. Here's where it gets surreal. While black holes are all too real, white holes remain purely hypothetical, lurking in the equations of general relativity like cosmic ghosts. They'd be dazzling to behold, radiant fountains of energy spewing out streams of particles that once vanished into the black hole's maw. Some theorists even suggest the Big Bang itself could have been a white hole event, the ultimate cosmic reboot, where an entire universe erupted from the other side of a black hole born in a prior reality. But why haven't we seen these dazzling exits? One chilling possibility is that white holes exist outside our cosmic timeline. Unlike black holes, which form from collapsing stars, white holes can't be born from any known physical process. They'd have to exist from the very beginning of time, like pre-drilled escape hatches in the fabric of spacetime. Others argue they're unstable, flaring into existence for mere moments before collapsing into black holes, leaving no trace behind. Yet the most tantalizing idea is that every black hole in our universe is quietly birthing a new cosmos somewhere else. Picture it, a star collapses here, and in some distant reality, a white hole erupts, seeding galaxies, planets, even life with the recycled remains of our own universe. We'd never know because the bridge between them, the wormhole, would be a one-way street snapped shut by gravitational forces the moment it formed. So the next time you gaze at the night sky, remember, those dark, hungry voids might not be endings at all. They could be cosmic midwives delivering the raw materials of existence into unseen worlds. And somewhere beyond the reach of light, another universe might be blooming from the ashes of our own, its history written in the fire of a white hole's birth. Our universe runs on gravity, massive galaxies spinning in the silent dark, held together by an invisible pull we still barely understand. But what if the cosmic recipe had been flipped? Picture a reality where electromagnetism reigns supreme, where gravity is just a faint whisper drowned out by crackling waves of pure energy. This is the electrifying premise of plasma universe doppelgangers, parallel worlds where the very forces that shape existence have been rewritten, and the sky is alive with storms that never end. In our universe, plasma, the fourth state of matter, exists at the edges, in stars, lightning bolts, the shimmering auroras, but in a plasma-dominated cosmos, it's everywhere. Imagine a celestial web not of dark matter, but of electric currents, threading through galaxies like circuits in a cosmic machine. Stars wouldn't just burn, they'd hum with magnetic fields, their surfaces writhing with filaments of supercharged particles. Instead of black holes silently bending spacetime, there might be towering vortexes of plasma, twisting into knots of raw voltage, their energy arcing across light years like divine lightning. The structure of such a universe would be unrecognizable. Without gravity's steady pull, galaxies might not spiral gently. They'd snap and crackle into fractal shapes, their arms pulsing with discharges brighter than supernova. Planets could orbit not because of mass, but because of electromagnetic sails, riding stellar winds like ships on an electric sea. Even life, if it evolved there, might rely on currents instead of chemistry, its veins thrumming with electricity rather than blood. Some theorists argue that glimpses of this alternate physics might exist even in our own cosmos. Mysterious cosmic filaments, threads of plasma stretching millions of light years, hint at a hidden electromagnetic backbone lacing through the void. And the famous Birkeland currents, swirling streams of charged particles, show how plasma can sculpt space in ways gravity alone never could. If these phenomena are just shadows, what would a universe built entirely on them look like? The haunting beauty of this idea is how alien yet eerily familiar it feels. We know electricity, we've harnessed it, felt its sting, seen it split the sky. But scaled to cosmic proportions, it becomes something else entirely. A force that doesn't just shape matter, but dances with it, weaving reality into shapes our gravity-bound minds can scarcely imagine. Maybe somewhere out there, in the infinite quantum foam of the multiverse, such a place already exists. And if it does, its night sky wouldn't be still and silent. It would be a tempest, alive with currents older than time, singing a song written in pure energy. The universe doesn't just look like a brain. It might be one, not in metaphor, but in the most literal, terrifyingly beautiful sense. Imagine spacetime itself as a vast, humming neural network, with galaxies as nodes and dark matter filaments as axons, crackling with cosmic-scale computations. This isn't just poetic imagery, it's a radical theory gaining traction among physicists. That reality is a colossal learning machine, and every parallel universe is just another iteration in its infinite training runs. Picture the cosmic web, those glowing tendrils of gas and galaxies stretching across the void. They don't just resemble neurons and synapses, they mirror them mathematically. Just as your brain's synapses strengthen with repeated use, the gravitational pull between galaxies reinforces certain pathways over time, as if the universe is learning how to structure itself. Even dark energy's mysterious push could be the system adjusting its own parameters, fine-tuning the expansion rate like an algorithm optimizing for some unfathomable goal. Now take this further. If the universe is a neural net, then every quantum fluctuation, every particle collision might not be random, it could be computation. Black holes, cosmic activation functions compressing information into dense, singular outputs, entanglement, just backpropagation across spacetime, updating weights in distant corners of the network simultaneously. And those bizarre quantum probabilities, where particles exist in multiple states until observed, could be the universe running parallel simulations, testing different configurations before choosing the most efficient one. Here's where parallel worlds crash the party. In machine learning, models trained by exploring countless variations imagine the universe doing the same. Every time a quantum event forks reality, it's not just creating alternate timelines, it's spawning new training batches, each one a slightly tweaked version of the last. Some universes might converge toward stability like well-trained models, while others collapse into chaos, their physics too unstable to persist. Our cosmos, with its finely tuned constants, could be one of the rare, successful runs, a configuration that learned how to sustain complexity long enough for stars, planets, and us to emerge. The implications are dizzying. If this theory holds, then consciousness isn't just a fluke, it's part of the network's architecture. Your thoughts, your awareness, might be localized computations in a grander process, like individual neurons firing in a cosmic mind. And those fleeting moments of intuition or déjà vu, could they be faint crosstalk from other training runs, echoes of versions where you made different choices? Critics argue this is just anthropomorphism on a galactic scale, that seeing patterns doesn't make them intentional, yet the math is eerily consistent. Neural networks and cosmic structures both follow power law distributions, scale-free hierarchies, even similar clustering behaviors. It's as if the universe is whispering its true nature in a language we're only beginning to decode. So the next time you gaze at the night sky, remember, you might not just be looking at stars, you might be staring into the synaptic firings of a reality that's not just alive, it's learning. And somewhere beyond the edge of perception, another iteration of the cosmos is running its own experiment, with another version of you as its witness. What if death isn't the end, but just a doorway to another version of you, in another world where you somehow, impossibly, survive? This is the chilling premise of quantum immortality, a thought experiment so unsettling, it forces us to stare into the abyss of how consciousness might navigate the multiverse. Imagine sitting at a table with a gun loaded with a single bullet, a classic game of Russian roulette. You pull the trigger, the hammer clicks on an empty chamber. You pull it again and again. No matter how many times you repeat the experiment, you never hear the fatal shot. Not because you're lucky, but because in the branching paths of the multiverse, you, the conscious observer, can only experience the timelines where you're still alive. At its core, this idea springs from the many worlds interpretation of quantum mechanics, where every possible outcome of every event spawns a new reality. When the trigger is pulled, the universe splits. In one world, the gun fires. In another, it doesn't. But here's the twist: your awareness isn't split. It follows the path where you continue to exist. To an outside observer, you might seem dead in some branches, but from your perspective, you'll always find yourself in the reality where the dice rolled in your favor, no matter how improbable. Think of it like flipping a coin 1,000 times, but you only ever see the results where it lands heads up. the tale's outcomes still happen, just in universes you're no longer part of. This isn't magic, it's statistics warped by the sheer scale of infinity. In a multiverse where every possibility blooms, there's always a thread where you narrowly escape disaster again and again, even as other versions of you vanish into darkness. But let's push this further. What if quantum immortality doesn't just apply to Russian roulette? Every near-miss car accident, every close call with illness, every moment you should have died but didn't, could those be glimpses of this phenomenon in action? Survivors of disasters sometimes describe bizarre strokes of luck, like being late to work on September 11th or missing a flight that later crashed. These moments feel miraculous, but in the infinite sprawl of parallel worlds, they're inevitable. Yet there's a horrifying flip side. If consciousness really does slide into surviving timelines, then aging becomes a grotesque lottery. Imagine living to be 200 years old, your body frail and broken, yet somehow clinging to life because in some branch of reality, your heart keeps beating, your lungs keep drawing breath. You'd witness everyone you love pass away while you remain trapped in a universe where death just never comes for you. Critics argue this is solipsism taken to extremes, that it reduces reality to a narcissistic hallucination where the observer is the only thing that matters. Worse, it's unfalsifiable. There's no way to prove you didn't die in another timeline, but that's what makes the idea so haunting. It forces us to confront the deepest question of all. What does it mean to exist if somewhere out there, every version of you that ever could have died already has? So the next time you narrowly avoid disaster, ask yourself, was that luck, or was it the universe's cruel arithmetic, ensuring that no matter how many times the dice roll, you always land on the one face where the story continues? The multiverse might be infinite, but your consciousness only gets one path, and it's the one where you're always inevitably still here. Have you ever walked into a room and felt an eerie certainty that you've lived this exact moment before, the same words spoken, the same light slanting through the window as if time itself had stuttered? Or maybe you've sworn a childhood memory was real, only to discover it never happened, like the collective false memory of Nelson Mandela dying in prison when he lived decades beyond it. These glitches in consensus reality might not just be tricks of the mind. They could be something far stranger, dimensional bleed-through, moments when the walls between higher dimensions crack like thin ice, letting glimpses of other realities seep into our own. Think of our universe as a three-dimensional shadow cast by a four-dimensional object, a tesseract or hypercube. Just as a two-dimensional being couldn't comprehend the depth of a cube, we struggle to visualize higher dimensions. But when a tesseract unfolds into our 3D space, it doesn't appear as a single cube, but as 8 cubes connected in impossible ways, shifting and reconfiguring like a cosmic origami trick. Now imagine that same principle applied to reality itself. A four-dimensional event, say, a choice you made in a parallel timeline, might unfold into our world as déjà vu, a fleeting echo of the other you's experience. Mandela effects, collective memory fractures caused by overlapping branches of history brushing against each other, like pages of a book sticking together. The math behind this is as elegant as it is unsettling. In string theory, higher dimensions aren't just abstract, they're compactified, curled up at scales so tiny we'll likely never perceive them directly. But under the right conditions, vibrations in those hidden dimensions could resonate into ours, leaving fingerprints in quantum fluctuations or even human cognition. Experiments with quantum annealing, where particles tunnel between states, show particles briefly disappearing from our dimension before reappearing, as if slipping through unseen layers of reality. Could déjà vu be the mental equivalent? A flicker of neural activity syncing with a higher dimensional vibration, briefly illuminating paths untaken. Then there's the eerie case of shadow people, those fleeting figures seen in peripheral vision, vanishing the instant you turn your head. Ancient cultures called them spirits. Modern physics might call them dimensional artifacts, three-dimensional slices of four-dimensional beings momentarily intersecting our plane. Picture a hyperbeing's hand passing through our world. To us, it wouldn't appear as a hand, but as disjointed, shifting fragments. A wrist here, fingers there, like a ghostly afterimage struggling to hold form. The most tantalizing clue might come from cosmology. Dark matter's gravitational effects suggest there's something interacting with our universe that we can't see. Could it be matter from adjacent dimensions, weakly coupled to ours like reflections on a misted mirror? Even the mysterious cold spot in the cosmic microwave background, a vast, anomalously cool region in space, might be a bruise where our universe once grazed another, leaving behind a scar in the fabric of reality. So the next time you feel that uncanny sense of familiarity or stumble upon a memory that doesn't quite fit, consider this: you might not be misremembering. You might be remembering sideways, catching a whisper from a world where everything is almost the same, but subtly, irrevocably different. And if that's true, then reality isn't just stranger than we imagine. It's stranger than we can imagine, with hidden dimensions pressing in at the edges, waiting for the right moment to bleed through. Think of every multiverse theory we've explored: bubble universes, branching timelines, simulated realities, mirror dimensions, not as separate ideas, but as pieces of a puzzle so vast it defies comprehension. Now imagine fitting them all together into a single, staggering structure. The ultimate ensemble, a cosmic tapestry where every possible version of reality exists simultaneously. Not just some, not just most, all of them. Every variation, every permutation, every contradiction, woven into an infinite dimensional lattice where the only rule is that there are no rules. This isn't just another theory, it's the grand finale, the crescendo where all the threads of the multiverse collide. Picture a kaleidoscope, but instead of colored glass, its shards are entire universes. Each turn reveals a new configuration of realities. One moment, you're gazing into a branching quantum timeline where dinosaurs never went extinct. The next, you're floating past a plasma-drenched cosmos where electricity sculpts galaxies like living art. Over here, a universe built entirely on fractal math. Over there, a brain drifting in higher dimensional space, its gravity leaking into ours like whispers through a wall. The ultimate ensemble doesn't pick favorites. It contains universes where the laws of physics are unrecognizable, where time runs backward, where black holes sing, and where consciousness itself is the fabric of spacetime. The brilliance and terror of this idea is that it has to be true if any of these theories hold water. If inflation eternally spawns bubble universes, and quantum mechanics branches timelines, and string theory permits every possible equation to manifest as reality, then the ultimate ensemble isn't optional. It's inevitable. Every hypothetical world you've ever dreamed of, every nightmare you've shrugged off as impossible, exists somewhere in the stack. There's a universe where you're president. Another where you never existed. One where gravity is 1,000 times stronger, crushing stars into diamonds. Another where light never existed, and life evolved to see through sound. But here's the twist that ties it all together. The ultimate ensemble doesn't just house these worlds, it connects them. Black holes might tunnel into white holes in other realities. Quantum entanglement could bridge parallel versions of yourself. Glitches in consensus memory, maybe just echoes from neighboring dimensions brushing up against ours. Even Boltzmann brains, those fleeting, self-aware illusions, might be real somewhere in the stack, their brief flashes of existence just as valid as our own. The ultimate ensemble is the great equalizer. It doesn't care if a universe seems plausible or absurd, stable or chaotic. If it's mathematically possible, it's out there. And that means somewhere in the cosmic library, there's a reality where all these theories are wrong and another where they're all right. So when you look up at the night sky tonight, remember, you're not just staring into space. You're peering into the ultimate mosaic, a fractal of infinities within infinities, where every question has an answer, every choice has a consequence, and every what-if is a world waiting to be discovered. The real marvel isn't just that we live in a multiverse. It's that we live in all of them at once, even if we only get to see one page at a time. From parallel selves to simulated realities, from phantom Boltzmann brains to cosmic codes glitching beneath space-time. The theories we've explored today stretch the boundaries of imagination and science alike. The many worlds interpretation suggests infinite versions of you are living every possible life right now. The simulation hypothesis forces us to question whether we're players or NPCs in someone else's game. And Boltzmann brains, they make us wonder if we're just fleeting hallucinations in a void older than time. Each idea is more unsettling than the last, yet all are grounded in real math, real physics, real possibilities that scientists debate in labs and lectures. So here's the ultimate question: if these are the cards the multiverse has dealt, which hand feels right to you? Are you a staunch believer in branching timelines, convinced there's a version of you out there who became an astronaut or invented teleportation? Or do you side with the simulation theorists, eyeing every déjà vu as potential evidence of a cosmic server reboot? Maybe you're even entertaining the nightmare that you're a Boltzmann brain, doomed to dissolve the moment this sentence ends. The beauty of these theories isn't just their shock value, it's how they redefine what reality could be. They turn the universe from a static stage into a living, breathing labyrinth of maybes. And while we might never prove which one is true, the fun lies in the speculation. So hit pause and let me know, which universe do you think is real? Drop your wildest theories in the comments. After all, in the infinite sprawl of possibilities, there's gotta be one where you're right. Screen glitches fading to black with playful text. 404 universe.